So today we start lecture 66 on our helicopter dynamics course, and today I'm going to discuss Coriolis forces. These forces are the source of nonlinear terms in the flap lag equation, and we will take a look at the genesis of these forces today. I'm Dr. Ranjan Ganguly. Now if we look at these two rotating disks here and we think of a mass m, and let's take the first case where this mass m is there and it starts moving forward. That means beyond the speed of this rotation here, it acquires an extra velocity. Then what will happen is that there is a Coriolis force which is going to act, which is going to push the mass out in the radial direction. So that's the direction of the Coriolis force. In the second case, let's consider a mass here, and this mass tries to move inwards with the velocity v towards the center of this disk. Now in this process, this mass is going to acquire a force in the circumferential direction shown here, and that's the Coriolis force seen by this mass. So in both these cases, Coriolis forces come because there is a moving mass in a rotating system. That's the genesis of Coriolis forces. So we'll look at both these situations and try to think of it more physically and then look at some expressions for these forces. So let's look at the first situation. Now just to make it more concrete, let us imagine there is a person here. This is a huge rotating disk, and this person starts walking in a circular path in the direction of rotation. Now as this person starts walking, he gains more angular momentum than is needed to maintain the equilibrium condition. The result is that he is pushed outward toward the region which has larger angular momentum. And therefore this person starts feeling a force which pushes him radially outward from the center of this rotating disk. Now let us say this person has a mass m, then this Coriolis force is going to be equal to twice rotation speed into mass into velocity, where this v is the velocity of the person who is moving along the circumferential direction. So that's the magnitude of this Coriolis force. Now let's consider the second case. Now here the person starts moving radially toward the center. Now in this process he enters a region which has lesser angular momentum than is required to sustain the equilibrium position in this region. Therefore he gets a push which is in the direction of rotation. So here the Coriolis force acts circumferentially in the direction of rotation here. So again, this Coriolis force is also given by twice rotation speed m into v, and now v is the radial velocity of this person. So remember, this person is going inside, he's encountering this Coriolis force in the circumferential direction. So these are the two types of Coriolis forces which we can think of in a simple manner by visualizing this particular situation of a person or a mass on the rotating disk. Now what happens in the flap lag problem is you have similar situations. You have the rotor disk, and essentially the flap and the lag displacements, these cause certain motion to the masses which essentially create Coriolis forces, and these Coriolis forces are the root or the genesis of the nonlinear terms which are very important for helicopter dynamics motion. So I hope you understood today what is the genesis of the Coriolis forces. Remember, the Coriolis forces are given by twice into rotation speed into m into v. And I will see you in the next video where we are going to discuss more about these forces with respect to the flap lag motion.